Hello everyone. Let me now explain the thought process and the idea behind the project. So, if you see recommender systems, there are two types basically: content-based and collaborative. Both of these mixed together is a hybrid model. So, in collaborative itself, this is user-based is there and item-based is there, other two subdivisions. So, user-based is basically finding similar users, and item-based is finding similar items and recommending. But our project is majorly concerned with content-based recommender systems, which is finding content and tags similar to the movies. So let me now tell what it is all about. So in the content-based filtering, a user will be interacting with a particular item, and we'll be finding items similar to that to it, and then recommending it to the user. So now it all breaks down to finding similar movies. So this is the entire project flow. Okay. So this may be a bit jargonish, like pre-processing data, vectorization, model building, and etc. But it's not very tough. Let me now break it down into very simple terms. So now the core process begins. So basically we have two dataset files over here. So out of which there are 23 unique columns, but we are only taking 7 columns which are required for the build. This can differ from project to project, model to model, and developer to developer. I am here taking movie ID, title, overview, genre, keywords, cast. In the cast also top 3 actors only, and then from the crew I'm taking the actor. By this I'm taking the required data, and then now I'll be structurizing it, because if you see the data frame, it is in different structure. We will be making down into the structure what we need, a simpler structure. So, and then we will also need to delete the spacing, because we need to avoid ambiguity these two things between two entities, right? For example, if a person is watching Sam Howard's movie, okay, he should not be recommended with Sam Carter's movie or something like that. Okay, if space is there, what happens is Sam is a different entity, Howard's a different entity. Here also Sam is different and Carter is different. So what happens is this Sam and this Sam gets, there will be an ambiguity with those two things. So to avoid all these things, we must reduce all the spacings. We must delete all the spacings. And then we need to join all the things and make it as a single tag column. And in this process, we'll be also doing stemming. Stemming is nothing but breaking down all into a root word. Okay, for an example, if you look at here, the consult is there, consulting is there, consultant is there. At the root level, all these things are having same meaning only, right? So to avoid duplication, we need to convert all these things into same word, that is consult. So and then we'll also be removing the stop words like a, they, etc. So now if you look at this, this is the pre-final thing, having all the columns which I'm telling, and then after this is the final data frame. Here just movie ID is there, title is there, and then tags is there. So now let me come to the next core process. Okay, that is the vectorization. Here all the tags are in text, right? We need to first convert that into numbers. Okay, to do that we'll be doing vectorization. So we are here taking 5,000 features. That means from out of all these tags, we are taking 5,000 maximum occurring words, and against every movie we will be taking the frequency of all those 5,000 words. So by that, we'll be getting a 5,000 in 4,806 into 5,000 matrix like this. So you can, for imagination purpose, I'm showing this. Here, there are 3 vectors, right? So indicating, just imagine it as 3 movies in a 2D plane. That means we are having 2 features. So, but here we are having 5,000 features and 4,806 movies. That means there are 4,800 vectors in a 5,000D dimension, in a 5,000 dimension. So imagine that in that way. That is how you must imagine this particular vectorization process. Now next comes the next biggest core process, that is the cosine similarity. So now we have all the vectors, right? We have many vectors. So now our major concern is to give the top 5 recommendation. Okay, for that we will be taking against every movie with every other movie, we will be taking the cosine similarity, because there are 4,806 vectors, and we'll be taking cosine similarity with every other vector. We'll be having all the values. So it is 1 because it is with the same vector, right? So after that, we'll be taking the top 5 values and recommending it. See, it is basically nothing but, if I am giving this as the vector, which is the movie which is being watched by the user, now all we need to do is find 5 other vectors which are closer to this vector, right? Do that cosine similarity helps. And by doing it, we'll be taking top 5 values, that is top 5 vectors which are closer to this particular vector. And then we'll be giving, and then we'll be returning. So when we get the movie ID, all is done, right? We'll be taking the poster images from the API, and then we'll be displaying it in a very nice interface. So that's it. I have explained the entire heart and the core processes which are involved in this recommendation project. So this is the final outcome, and the interface is built with the Streamlit. And that's it. You can look at my GitHub repo also. Thank you.